What if everything you thought you knew about global energy infrastructure was just the surface of something far more sophisticated? While governments and corporations publicly debate solar panels and wind farms, a network of advanced technologies is quietly reshaping how power flows across the planet. And it starts 22,000 miles above your head. We're not talking about conspiracy theories here, we're talking about documented science, published research, and operational systems that most people have never heard of. Right now, as you watch this video, satellites in polar orbits are monitoring energy consumption patterns across Arctic regions with precision that would have been impossible just 5 years ago. The European Space Agency's Aurora mission isn't just watching pretty northern lights, it's tracking electromagnetic disturbances that can knock out power grids across entire continents. When a solar storm hits Earth's magnetosphere, these satellites provide the early warning systems that keep hospitals, data centers, and critical infrastructure online. But here's where it gets interesting. Microsoft just deployed something called Aurora AI, a 1.3 billion parameter artificial intelligence model that processes over 1 million hours of atmospheric data to predict weather patterns with 5,000 times better computational efficiency than traditional forecasting. This isn't just about whether you need an umbrella tomorrow. This AI can forecast energy demand, optimize power distribution, and predict when renewable energy sources will be most effective across entire regions. Meanwhile, in the Arctic, something remarkable is happening. The Aurora line, a €270 million transmission system connecting Finland and Sweden, came online this year with 900 megawatts of cross-border electrical capacity. This isn't just a power line. It's part of a larger network of energy infrastructure designed to handle the volatile nature of renewable energy across northern regions where traditional grids struggle with extreme weather conditions. What makes this system truly sophisticated is how these components work together. Space-based monitoring systems track atmospheric conditions that affect energy transmission. AI algorithms process this data in real time to optimize power flow across international borders. Arctic infrastructure adapts to conditions that would shut down conventional systems.
Recent research from the Ted Stevens Arctic Security Center reveals how artificial intelligence is revolutionizing Arctic climate data science, enabling prediction of everything from ice formation patterns to energy infrastructure vulnerabilities. This isn't just academic research, it's operational technology that maritime companies use to plan routes and energy companies use to predict demand. The implications go far beyond energy management. When you can monitor space weather in real time, predict atmospheric conditions with unprecedented accuracy, and dynamically route power across international networks, you're essentially creating a responsive nervous system for critical infrastructure. During the 2021 Texas winter storm, similar systems in other regions helped prevent cascading failures by automatically rerouting power around damaged areas. What's particularly fascinating is how these systems address one of the most challenging problems in renewable energy: intermittency. Solar and wind power generation fluctuates based on weather conditions. Traditional grids struggle with this variability. But when you combine space-based weather monitoring, AI-driven demand prediction, and flexible transmission networks, you can anticipate these fluctuations and adjust accordingly. The financial implications are staggering. Research shows that AI-powered predictive maintenance reduces unexpected downtime by 40%, while AI-based demand forecasting reaches 90% accuracy in energy consumption predictions. Companies implementing these integrated systems report energy savings of up to 20% in industrial settings, with some facilities identifying millions in cost reductions through optimized energy usage patterns. Perhaps most intriguingly, this technology is enabling entirely new approaches to energy distribution. Space-based solar power research is advancing rapidly, with successful demonstrations of wireless power transmission from orbit to Earth-based receiving stations. While still experimental, these systems could eventually provide continuous clean energy without the limitations of terrestrial solar installations. The convergence isn't accidental. Arctic regions serve as testing grounds for extreme conditions, space-based systems provide global monitoring capabilities, and AI algorithms tie everything together with decision-making speed that human operators can't match. Each component enhances the others, creating capabilities that exceed the sum of their parts. This raises important questions about energy independence and security.
When your power grid depends on satellite data, AI algorithms, and international transmission networks, who controls the switches? How vulnerable are these systems to disruption? Recent concerns about critical infrastructure protection suggest these aren't just technical questions, they're national security issues. Looking ahead, the integration of these technologies appears to be accelerating. Major industrial facilities are increasingly dependent on AI-optimized energy management. Arctic energy infrastructure projects are expanding across northern regions. Space-based monitoring capabilities continue advancing with new satellite constellations and improved sensors. The next time you flip a light switch, consider the invisible network that made that simple action possible. Satellites tracked the weather conditions affecting renewable energy generation. AI algorithms predicted your energy demand and optimized distribution across the grid. Transmission systems automatically adjusted to maintain stable power flow despite fluctuating conditions hundreds of miles away. We're witnessing the emergence of a truly intelligent energy infrastructure, not through some shadowy conspiracy, but through the convergence of legitimate technological advances that are reshaping how civilization powers itself. The question isn't whether this network exists. The question is how quickly it will transform the way we think about energy, technology, and the invisible systems that keep our world running. What do you think? Are we heading toward a more resilient energy future, or creating new vulnerabilities we don't fully understand? Share your thoughts in the comments below and let me know what aspects of this technological convergence you'd like me to explore in future videos.